The global image of Albert Einstein is often frozen in this single frame, an eccentric, wild-haired brain detached from the world of people and politics. He never failed math. In fact, he mastered it as a child. What he actually failed to master was the rigid, rote learning style of German classrooms. To him, these schools were environments that prioritized obedience over actual thought. This refusal to accept established systems became his primary investigative tool. By rejecting the methods of his teachers, he developed a habit of interrogating the basic assumptions of the universe that his peers took for granted, a defiance that defined his physics and his life. Working as a clerk in the Swiss patent office, he processed complex physics outside the traditional university hierarchy. When a mathematical problem stalled, he picked up the violin, using music to navigate through the mechanics of the universe. In 1905, this solitary, unconventional approach yielded his Annus Mirabilis, his miracle year. He published 4 papers, including a mathematical proof of the existence of atoms and a proposal that light consists of individual packets called photons. Another paper introduced special relativity. He proposed that the speed of light is the universe's strict limit. Because of this, space and time are relative. They stretch and compress depending on how fast an observer is moving. These 4 papers were perfect abstractions. They were elegant, pure theory on a page, waiting to collide with the friction of a 20th century reality. 10 years later, he published General Relativity, shifting his focus to the nature of gravity. It is not an invisible force pulling objects, but a curvature of the fabric of spacetime caused by mass and energy. The scientific establishment validated his work in 1921, awarding him the Nobel Prize in Physics for his earlier discovery of the photoelectric effect. Within the realm of theory, his mind had successfully mapped the pristine, flawless mechanics of the universe. But outside of his perfect equations, the messy, violent reality of the 20th century was quickly descending into global conflict. His derivation of mass-energy equivalence, E equals mc², revealed that a terrifying amount of energy is locked inside standard matter. This discovery created a brutal moral friction. Fearing that Nazi Germany would develop a weapon first, the lifelong pacifist felt compelled to urge the United States to build the atomic bomb, a role he would later come to regret. He stepped out of his intellectual isolation to become a geopolitical actor. He joined the NAACP and worked to dismantle American segregation, calling racism the country's worst disease. He also championed Zionism, helping to establish the Hebrew University of Jerusalem as a secure center for Jewish learning amidst rising global persecution. The abstract theorist no longer existed in a vacuum. He was forced to take a physical stand against the violent currents of history. Today, those 1905 thought experiments form the invisible infrastructure of the modern world. Your phone's GPS relies on relativity to keep satellite clocks perfectly synced with the ground. His Nobel-winning theory of photons directly enabled the creation of modern solar energy arrays. That same photoelectric theory describes exactly how the sensor in your digital camera converts light into the pixels of a photograph. The abstract, perfect math of a century ago literally built the physical reality we navigate today. He spent his final years chasing a unified field theory and attempt to pack all the forces of nature into one master equation. He died in 1955 with that quest unfulfilled. Even in death, his desire for pure intellect was violated. His brain was removed without permission and taken for scientific study. The man who spent his life seeking the beauty of pure equations was the same man who stood on the front lines of the atomic age and the American civil rights movement. Einstein's legacy demonstrates that the pursuit of pure theory cannot be separated from its physical consequences. He proved that the person who writes the equations must also be the person who answers for how they change the world.